Channel, if you come across this type of question in your post-UME exam, this is how you are going to solve it. Let us read the question first. The question says an electron of charge, this is the charge of the electron, and mass, this is the mass of the electron, okay, is accelerated between two metal plates with the velocity, this is the velocity of the electron. The potential difference between the plates is what? What is the potential difference between the plates? First of all, let's bring out our parameters. Now, an electron of charge, this is the charge, so let's do that. Charge is 1.6 times 10 raised to the power minus 19 coulomb. That's the charge of the electron. And mass, the mass is what? 9.1 times 10 raised to the power minus 31 kilogram. Okay? Is accelerated between two metal plates with a velocity. Velocity is what? 4 times 10 raised to the power of 7 meters. Good. So this is your velocity of the electron. Then this is your potential difference. So let's do it this way. Mass of electron, velocity of electron, then this becomes your potential difference. Now let's do this quickly. Remember that potential difference, what is potential difference? Potential difference has a symbol V. Potential difference is the work done in taking a unit charge from one point to another, okay? Is the work done in taking a unit charge. So the formula for potential difference is work done over charge. That is to say, we are going to get work over charge. Where is the work coming from? Remember that the electron was accelerated from one plate to the other plate. That is to say, the work that was done was to move the electron from one metal plate to the other metal plate. And since the electron is in motion, it means that the work done is equals to your kinetic energy. And you remember vividly that kinetic energy is half mv squared. This is the mass, this is the speed of the electron. This will make our potential difference to be what? Half mv squared over charge. Please, it must be noted. So how do we do it now? We have 1 over 2 times the mass of the electron. Look at it. It is 9.1 times 10 raised to the power minus 31 times, and the speed of the electron is 4 times 10 raised to the power of 7. So you have 4 times 10 raised to the power of 7 all squared all over your charge. What's the charge of the electron? 1.6 times 10 raised to the power of what? Minus 19. So let's do it quickly. Good. So we have, first of all, we have 1.2 times 9.1 times 10 raised to the power of minus 31 times, remember that this is squared. If you square 4, you have 16. Then if you square 10 raised to the power of 7, you have 10 raised to the power of 14. It's like having 10 raised to the power of 7 times 10 raised to the power of 7. That will give you 10 raised to the power of 7 plus 7, 14. Remember the laws of indices. You are not expected to multiply the power. You only add it. Or you simply use 2 times 7 to give us what? 14. All over 1.6 times 10 raised to the power of what? Minus 19. So first of all, I'm going to use this 2 to cancel 16. And that's going to give us 8. So we have 9.1 times 10 raised to the power of minus 31 times, here is what? 8 times 10 raised to the power of 14 all over 1.6 times 10 raised to the power of what? Minus 19. So we are going to use our calculator to do what? Our potential difference will be equals to what? Watch this. Remember, your calculator that will be given to you in your post-UME exam or your JAM exam usually do not have the exponential button. So what we'll do 9.1 times 8. Then we'll divide by 1.6. That's what we'll do first. So we have 9.1 times 8. We'll divide it to what? 1.6. Then what happens to this 10? This one, this one. You simply pick one of the 10. Then for this one that you have times between the 10, you add it. So you have minus 31 plus 14. But when you have divide, you minus it. So you have minus 19. So let's use our calculator to do this simple arithmetic. You have 9.1 times 8 divided by 1.6. So you have 45.5. So when we do this, we have 45.5 times 10 raised to the power of minus 31 plus 14. Minus is plus, so plus 19. So you have 45.5 times 10 raised to the power of minus 31 plus 14 plus 19. You have it as 2. Okay, so you have 2. Wow. Okay, you have 2. Minus 31 plus 14 plus 19. So you have it as what? 2. So you have it this way. Or if you move your point here, you have 4.55 times 10 raised to the power of 3 volts. So it's either you leave it this way. So we are likely to say that, okay, so this should be 3. This should be 3. So you have 4.55 times 10 raised to the power of 3 volts. So the answer is what? A. Just one more question. Call it today. Solve this second question. A solid weighs 10.0 Newton in air. Okay, so the weight of the solid in air is 10.0 Newton. Then 6.0 Newton when fully immersed in water. So the weight of the solid in water is 6.0 Newton. Follow me carefully. Okay? And 7.0 Newton when fully immersed in another liquid X. Weight of the object in a liquid called X is 7.0 Newton. They now said, what is the relative density of the liquid? Very easy. How do you solve it? Remember that relative density is equals to upthrust in the liquid. Upthrust in the liquid over upthrust in water. You must note this down. Now, what does upthrust in the liquid means? It means weight of the object in air minus weight of the object in the liquid, which is called what? X. Then, what does upthrust in water means? It means weight of the object in what? Air minus weight of the object in what? In water. So when we say upthrust, we are talking about the apparent weight loss. So what's weight of the object in air? 10 minus weight in liquid is what? 7. What's weight in air again? 10. Weight in water is what? 6. So we have 3 over 4. That's the answer. So the answer is not A, it is what? Not B. Please be careful. It is 3 over 4, not 4 over 3. So the answer is what? C. Thank you very much. We have come to the end of today's video lesson. If today is your first time for coming across my YouTube channel and you are preparing for WAEC, JAM or post-UTME exam, please do well to subscribe to this channel for more content. Thank you very much. I'll see you in my next video.